Alright, I'm back. So starting off where the last video left off, we were talking about how when we multiply 2 times the third root of 2 by the third root of 2, we were talking about that because our second term is 2 times the third root of 2, and we're going to multiply by third root of 2 again to get this second term. So when we do that, I went down here, I rewrote it. So our second term was 2 times the third root of 2, and we're going to multiply it by the third root of 2 again, because that is our constant multiplier up here. So when we do that, you multiply your leading coefficients, so 2 times, technically there's a 1 here, so multiply the coefficient, so 2 times 1, that's where we get 2, and then you multiply your radicals together. As long as they have the same index, you can multiply the radicals. So index of 3, we keep our index of 3, and then you multiply what's inside. So 2 times 2 is 4. So that's where we get the third root of 4. So 2 times the third root of 2 multiplied by the third root of 2 again is 2 times the third root of 4. So we go ahead and we write that in our next space up here. We have 2 times the third root of 4. And then we're going to multiply 2 times the third root of 4 by the third root of 2 again. And we should get 4. So doing that, I'm going to come back down here and take our term that we have now, 2 times the third root of 4, and we're going to multiply that by our constant multiplier, which is third root of 2. When we multiply those together, remember you multiply your coefficients. There's technically a 1 here. So 2 times 1 is 2. And then third root of 4 times third root of 2 is you keep your index, third root, and you multiply what's inside. So 4 times 2 is 8. So you may say, well, 2 times the third root of 8 is not 4. Or it's not fully simplified yet. So if we break down or factor 8, we get 2 times 4, and then 4 can be factored into 2 times 2. So remember, our index tells us how much we need in order to pull it out. So we need a group of 3. Well, we have a group of 3 2's here. Is there anything left over? No. So you pull out this 2, and there's nothing left inside the radical. So you get 2 times, we pulled out a 2, which is 2. So, and 2 times 2 is 4. So that's why 2 cube root 4 times cube root 2 is 4. And then you'll actually notice a pattern. If we multiply 4 times our mini multiplier, which is the cube root of 2, it continues. Cube root of 2, cube root of 2, cube root of 2, times the cube root of 2, times the cube root, times the cube root of 2. It continues. So 4 times the cube root of 2 is 4 cube root 2. We cannot put those together, just like we couldn't put 2 and cube root 2 together. And then you'll actually see a pattern. When you multiply that again, you're going to get 4 times the cube root of 4. So there's a pattern going on. Cube root 2, cube root 4, cube root 2, cube root 4, whole number. So that's how you fill in the table. And then the last part is finding the explicit equation. So remember I told you guys the explicit equation for an exponential is y equals. You have 3 spaces you need to fill in to the x minus blank. So this first space is going to be your first y value, and you're going to multiply, that's what that big dot is for, you're going to multiply by your pattern between whole numbers. So what did we multiply by? Every whole number, and then it's going to be taken to the power of x minus something, and that something is your first x value. So going back to our table, we have to find what is our first y value, what is our pattern between whole numbers, between 0 and 1, 1 and 2. What did we multiply by? and then what is our first x value. So if we go back to our table, our first y value is 2. So I'm just going to write that down here. So first y value is 2. We need the pattern of whole numbers. And we need our first x value. So let's go back up to the top. Pattern between whole numbers, 0 and 1, 1 and 2. What did we multiply by between 0 and 1? What did we multiply by between 1 and 2? Well, between 0 and 1, 2 to 4, we multiplied by 2. 4 to 8, we multiplied by 2. So the pattern between whole numbers is 2. So we go back down here. The pattern between our whole numbers was 2. And then we go back up to the top. What was our first x value? Well, our first x value was 0. So we go back down to the bottom, and our first x value is 0. So we can write our equation. I'm going to write on another piece of paper. We can write our equation as y equals, our first y value was 2, times our pattern between whole numbers was also 2, to the power of x minus 0. So if you left it like that on the test, I would give you credit, but you could simplify this. X minus 0 is not going to make a difference. You're always going to get x, so we can get rid of the 0. So we have 2 times 2 to the x. And then you can combine these. 2 has an exponent of 1. And when you're multiplying powers that have the same base, then you keep your base and you add your exponents. So this y equals 2 to the x plus 1 would be our equation for that table. So again, remember this pattern for all exponential equations. Y equals the first y value times the pattern between whole numbers to the power of, or to the exponent of, x minus your first x value. So please write what you need to on your cards and your note cards for the retake.